Assalamu alaikum students. Welcome to another video. This is question 3 of exercise 10C. It is for LS2 and 3. So let's move on. Question 1 and 2 were done in the classroom videos which were available on the Pingu's official page. So this is question 3. Let's read. Convert each of the following angles from degrees to radians, leaving your answer in terms of pi. Okay, in terms of pi means that the answer which you will be getting, it should contain pi in it. Okay, so let's start solving. Okay, so here I've written something here that 1 pi in radians is equals to 180 in degrees. Okay, as we have seen this in previous questions as well, question 1 and question 2. So 1 pi is equals to 180 degrees. This is how pi and degrees are related. Okay, so I have to convert 15 degrees into radians. How much 15 degrees would be in radians? Okay, so the first step would be to multiply 15 on both sides. Okay, the first and the easiest step, multiply 15 on both sides is equals to 1 pi or simply pi in radians. Okay, and 180 degrees multiplied by 15. Okay, I've multiplied 15 on both sides. Now as the solution is required that I have to find how many is 15 degrees in radians, so on the right side on the equals to sign I would only be requiring 15 degrees here. Okay, not 180 degrees. Okay, so let's see. So here 180 is multiplying, on the other side it will divide. Okay, so 15 multiplied by pi divided by 180 degrees, and this side as you know is the radian side. This side is in, all the values are in degrees, so 15 degrees is left here. Okay, now you can see here 15 is alone here. It means that when I will solve this side will be equals to 15 degrees. Okay, 15 degrees equals to this side, and the answer when I solve this would give me the value in radians. Okay, so now I can simplify this. 15 upon 180, 15 times 1, 15 times 12 is 180. So what is left? Pi by 12 in radians equals to 15 degrees. This is our answer. 15 degrees equals to pi by 12 in radians. Okay, very simple question. Now similarly I have the part B here. Very easy. We will do the same solution here. 1 pi equals to 180 degrees. Multiply 18 on both sides. 18 multiplied by 1 pi or only pi, it depends upon you, equals to 180 degrees multiplied by 18 degrees. Again I only want 18 here because I want the answer of 18 degrees in radians. So 18 would be alone here. 18 degrees, 180 is multiplying, on the other side it will divide. So 18 multiplied by, I'm only adding pi here. 1 pi is simply pi. Now here I will divide 180 degrees. 18 degrees is equals to, you can see here I can simplify this fraction here. 18 times 1, 18 times 10, pi by 10 equals to 18 degrees. This is our answer here. Simple. Now let's move on to question number 4. As you can see here, find the value of the following where all the angles are in radians. Okay, for this you will be requiring a scientific calculator here. So before starting this exercise, because this exercise is dealing with radians, make sure that your calculator which you are using is in radians. So you can see here there is an R which is eliminated here. It means that the calculator is in radians. Okay, so I will show you how to convert it. Shift setup, this will give you the menu here. Here you can select either to convert your calculator into degrees or radians. So if I want this to be converted into radians, I will simply press 4. You can see here 4 equals to radians. I will simply press 4 here. Now the calculator is in radians here. The R is eliminated. It means that the calculator is in radians. Okay, so it's a very easy question. You just have to put the value sine 0.8. Just put the values sine 0.8 bracket closed, 0.717. You can see here 0.717. This will give you the answer 0.717. Assalamu alaikum. So here we have question number 5. For each of the following, find the value of x in the range from 0 to pi by 2. Okay, this is the range of x starting from 0 till pi by 2. Don't be confused by this. The answers which we will be getting here of x will lie between these two extreme values. Okay, this is the range, and the answer which we'll be getting, it will lie between these two values. Okay, so now let's solve it. Part A, sine x equals to 0.74. So I have to find the value of x only. Okay, sine x equals to 0.74. So how will I find the value of only x here? Okay, equals to 0.74. I only want x here. Okay, so I don't want this sign here, I want x to be alone. So whenever we send a trigonometric identity on the other side of the equal sign, it changes. Okay, as we have done this previously in class as well. So x equals to sine, it will, when it will go here, it will be sine inverse sine is here. Okay, so now 0.74 is the angle now of sine inverse. Okay, the value which is written after this, after the trigonometric function, is called the angle. Okay, it can be either in radians or in degrees, or whatever value is written here, so it will be the angle of the sine. Okay, so x equals to sine inverse. So again we'll be needing the calculator here. Sine inverse, you all know how to find. Shift sine. Shift sine gives you the value of sine inverse here. Okay, now I will put the value. What value is required? 0.74. I will put the value 0.74 equals to 0.833. You can see here 0.833. This is the value of x. Simple answer. Now let's solve the other part here as well. So same we will do the same procedure here. Cos is here, it will be cos inverse on the other side. Cos inverse 0.17. X equals to cos inverse 0. Let's see, shift cos 0.17. It is 1.399. You can see here 1.399. This is the value of x. Simple. This is our answer. Okay, now part A and part B are done. The rest of the question you have to try them out by yourself, and do practice this question. Okay, so here we have exercise number 10C, question number 6 here. In triangle ABC, as you can see here, it's a right angle triangle. So ABC would be 90 degrees. It is also mentioned here, ABC equals to pi by 2. Pi by 2 in degrees would be 90 degrees. It's very easy, you can try to convert it by yourself. Okay, so pi by 2 is 90 degrees. ABC is 90 degrees. Given that AB equals to 8.7, in the segment AB is 8.7 centimeters, and angle CAB equals to 0.93, and angle CAB is 0.93 degrees in radians. Okay, calculate the length of segment BC, segment AC. First we will find BC here. Okay, why I've written all these values here? Okay, now so this is a right angle triangle, and we have to find here BC, which is an unknown side, and AC, this is AC. So whenever there is a right angle triangle involved, we use trigonometric identities here. These are the trigonometric identities we have written here, and there was a very easy way to memorize all these formulas. There was a sentence, some people have curly brown hair till painted black. So sine theta equals to perpendicular upon hypotenuse, cos equals to base upon hypotenuse, and tan theta equals to perpendicular upon base. Okay, so in this diagram, which side will be my base and which side will be my perpendicular? For that to understand, I've drawn the diagram here. You can see here the side which contains the 90 degree and the angle is called the base. Okay, if this angle was given to me, for example, not this angle, if this angle was given to me, so this side will be containing the 90 degree, and the angle given to me would be at this side, so this side will be my base then. Okay, so in this example I have the angle here, and the 90 degrees making on this side, so this side contains the 90 degree also and the angle given to me also, so this side will be my base. Okay, and the side which is perpendicular to the base is called the perpendicular, and this side never changes. Okay, the inclined side is always called the hypotenuse. Okay, now I have to find BC here. So it is, now I can easily mark all the sides here. This side is my base, and BC, as you can see here, this side will be my perpendicular, and this side is my hypotenuse. I'm just writing H for it. Okay, so base is given to me and the angle is given to me. I have to find the perpendicular first. So which formula has base and perpendicular in it? I have to see it. Okay, base and perpendicular, base and perpendicular. Okay, here perpendicular and base. I will use tan theta formula. Okay, theta is given to me, the angle 0.93, perpendicular I have to find, and base it is given to me 8.7. Okay, so let's start solving. Tan theta equals to perpendicular upon base. Tan angle is 0.93 in radians. Perpendicular I have to find BC, so I will simply write BC here, divided by base. Base is given to me 8.7. So I have to find BC here, so I will try to make this side BC alone and take all the other things on the other side. Here 8.7 is dividing, on the other side it will multiply. It's very easy. 8.7 multiplied by tan 0.93 equals to BC. You can solve these. Okay, make sure before you start solving, your calculator should be in the radians setting. Okay, now we have to put the values here. 8.7 multiplied by, bracket open, always put the brackets, so your answer, there should not be any error in your answer, so always put the brackets to avoid any confusions. 0.93, 11.66 you can see here. Okay, this is the length of the side BC. It is 11.66 centimeters. Okay, now we are on to part number 2 here. Segment AC we have to find. AC, as you can see here, is this segment, hypotenuse, and base we all know here. So I will use the formula which contains base and hypotenuse. Base and hypotenuse, you can see here, base and hypotenuse. Yes, here base and hypotenuse. So I will use the formula for cos here. Okay, similarly as we did the first part. So we have here cos theta equals to base upon hypotenuse. Theta is our angle, so cos angle is 0.93 here. Base, as we know, is 8.7 here, so I will simply write base 8.7 here. Hypotenuse we have to find, so I will simply write the segment name AC. Now I have to find AC, so AC will be transferred on that side, and this cos 0.93 will be divided here. Okay, their sides will be exchanged to, with one another. Okay, so AC equals to 8.7. Now cos will be, this whole value will be divided here, cos 0.93. so 8.7 divided by 8.7 divided by cos 0.93. okay, 14.55. you can see here the segment AC has the answer 14.55.